morning. Sorry I'm a bit late. There were some internet issues and I'm hopeful they've been resolved. But if at any point it starts getting a bit jerky or odd, I do apologise. I'm trying to make them as good as I can, but we can't control the internet, unfortunately. So you've joined me today. We're going to be going through... It's not going to be a long video because it is something I've done before, but I wanted to do again because my believe it's my year 7s are doing this at the moment. So I wanted to make sure that I had a video that was supporting that, but it's useful for everyone at secondary school. Today we're going to be looking at gradient and specifically how we can then use those gradients for describing lines. So let's get straight into it. Okay, so we're going to go straight over to the whiteboard, and that's not the whiteboard, this is the whiteboard. That's just a picture of me in infinite loops. Right, so looking over at the whiteboard, and we are talking about any line. It doesn't have to be on a grid, so we're going to start off not on a grid, just any slope. And you'll notice from the title page I had for the slide had a picture of some skiing, like a mountain, from a game called Steep. Now, what we're talking about is how steep all these lines are. Now, we could just say that that's fairly steep, and that's quite steep, and that one's very steep. But that's not very descriptive. And what we really want is a way of describing exactly how steep it is. So instead of that, what we do is we use numbers. Now, I've seen it done with percentages, and near the end of the video I will mention how this goes to percentages. But what you need to do is work out, and it doesn't have to be at the end, so I'll do the next one from the middle. You find 2 points on the line and you work out how far it goes along, let's say 5 meters, and how far it goes up, 10 meters. And it doesn't matter that this doesn't look to scale. I'll try and make them look more to scale, but what we do to find the gradient in mathematics is just the rise divided by the run. Another way of saying this is how far up it goes divided by how far to the right it goes. And you'll notice I said to the right and not across. And I said up and not up and down. This is because going down is the same as going up a negative amount. And going to the left is the same as going to the right a negative amount. We will do some of those, but first of all we're talking about the positive gradients. So this gradient would be 10 divided by 2 would be 5. Don't worry about the fact that if you look at this with your eyes, 10, this looks smaller than this. In mathematics we use things called models. And a mathematical model, it's not like a model as in a man or woman who walks, and well, I guess even an animal who shows off clothes. This is a model as in a picture of a system where the numbers tell you exactly what the details are. We don't have to go from the ends. We could just choose 2 points along the line and make a right-angled triangle. Because this is a straight line, if this works, it will be the same for the whole thing, because you'll notice that it would be parallel lines that would make the longer one. So let's say this one is 2 meters, but this one is only 1. Well, I've told you the gradient is rise over run, or up divided by across. So the gradient would be 1 divided by 2, and you're allowed to have a gradient that is not a whole number. So there you go, 1 over 2. We can also take it from one end and the middle, or it doesn't have to, these 2 points can be taken from anywhere along the line. Now, if you're on squared paper, which I believe I can suddenly make myself on squared paper, which is quite fancy, what you ideally want to do is make it so that you're choosing 2 corners that are on the corners of squares, so you can literally count them. And you can see here, I don't know how good the video is, but you can see here it's 1, 2, 3, 4, 5, 6, 7, 8 squares, and 1, 2, 3, 4, 5. So actually I've not done any guesswork here, I've literally just counted squares. then the gradient would be, and I keep calling it grad or G, but it's just short for gradient, which is how steep the line is going to be how far up divided by how far across. So it'd be 5/8. Okay. Good morning to Josh. Good morning to William and Claire. Good morning to anyone else who joins. First one is rise divided by run. Oh, oops. Good spot there. That should be 10 divided by 5, which is 2, and I put them the wrong way round. 10 divided by 5, rise divided by run, and the gradient is 2. Sorry about that. It's still a little bit stressful this morning. I was up late last night with my little babby, and she's had her first injections this morning, so she's a little bit tearful and things, so it's been a bit stressy, so that's why I'm a little bit all over the place, but my internet then not working didn't help. So here I'm going to draw another one, and I'm going to actually, to try and make it easier, I'm just going to actually draw an actual line. And I'd have liked it if it wasn't that thick, so let's see if we can make it a bit less thick. There we go. And I'm going to draw another one ready to use in a minute, which is going to be nice and shallow. And I'm going to draw one that's flat. And we'll talk about what flat lines do. So let's go through again. We need to find corners. So here's a corner, and here's a corner. So it goes 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. So the gradient is going to be the rise divided by the run. And you might notice that that's 2 1/3. We're all secondary pupils. We should be able to turn top of every fraction into mixed fractions. If you can't, I have videos on it. Go away and practice it. The next one, we move on to blue. Choose 2 points. This is quite a shallow one, so we'll go there to there. Remember, you just need 2 corners, which are squares, and this is 3 going up, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice one. So the gradient here is 3 divided by 9, but that simplifies down to 1/3, because 3 and 9 both divide by 3. But what do we do? Well, the thing is, we can't make a triangle here. It's impossible to make a triangle, because this one goes through the corner, and this one goes through the corner. Effectively, if we did make a triangle, it goes along 1, 2, 3, 4, 5, 6, along 6, and up 0. So the up is 0, and the along is 6. And if we do 0 divided by 6, we get 0. If you divide 0 by anything, you get 0. So this has a gradient of 0. The weird thing being, if you were doing a straight up line, and we'll squeeze one in this gap here, this has a gradient of infinity, which is a bit weird. And I'm going to write it like this, if you haven't seen infinity before. Infinity confuses lots of people because it isn't a number. It is an idea used to represent the idea that it is so big that we can't count it. It goes on forever. It's this idea that numbers can go on forever. And the reason is, it's because, let's say I chose this point here and this point here. It goes up 5 along 0, and 5 divided by 0 is error in your calculator. If you try and divide by 0, you'll get error, but it's infinity. It's because 5 sharing out 0 times, well, you can't share things 0 times. You can't divide it among 0 people. So it breaks a calculator, but because the answer would be infinity. Anytime you divide by 0, you get infinity. So they're the two extremes of lines. Straight up has a gradient of infinity, and straight flat has a gradient of 0. But we're looking at numbers between there. Let's go back onto some squares. I might even be able to put some slightly bigger squares so it's easier to read. So how can we use these gradients for negatives? Well, it's no different if the line points downwards. There's a shallow one. Oh, that's not very neat, is it? Oh, never mind. These will have to do. because I don't want to waste your time. And so what we're going to do is we're going to go from here to here, goes down to along 4. So the gradient here is -2/4. So the only thing that changes is the gradient becomes a negative. It doesn't actually change the calculations. It's still how far up and down divided by how far along, but it's a negative amount. And so these ones will all have negative gradients. If I choose 2 points, this point here, and if I had made this a bit straighter, it wouldn't be so bad. So let's make it a bit straighter. Dooby-dooby-doo. You have to always do the dooby-dooby-doo sound if you want to be accurate. And so I don't want to do it there. I want to start writing in red. And I want to find a corner. That's a corner. And we're going to go dooby-dooby-doo, dooby-dooby-doo, and we're going to go 5 and -4 because it's gone down, look. It's not gone up. So -4, 5. So the gradient is going to be -4 divided by 5. And you can turn that into a negative 0.8. You can turn it into a decimal if you wish to, or you can leave it as a fraction. So the gradients will always be either fractions or decimals. You can choose. This one, this is a corner, and this is just about a corner. It goes down to 1, 2, 3, 4, 5, 6. 6 along. So the gradient, I should be writing gradient each time, is going to be -2/6, which does simplify to -1/3. So we've got 3 negative gradients. Unfortunately, according to Eddie, I'm glitching. I do apologise if I'm glitching. I can't control it. Like I said, my internet has been a bit odd. So I do apologise to those people who are watching live or at a later date. If you've come in watching this, obviously, most of the views I get aren't watched live. They're watched later on, where people come in their own time and watch the video to find out what's going on. So hopefully you're still able to follow what a gradient is. Finally, how can we use this to describe a line on a graph? Well, if I quickly draw a graph like this and move it over so that it's on the line, because I don't like it when it's not on the line. There we go. If I have a line now that's on here, and this is what a lot of our year 7s at my school have been doing this week, is you need to be able to describe this line by being very careful. And the first thing we do is choose, just exactly as I've done before, we choose some points, do our calculation. This is 2 and 2, so the gradient equals 2/2, which is 1. Excuse me. Second thing you need to work out is what that number there is. So if that's 0, 1, 2. So it just so happens here we've got 2 is called the y-intercept. It's where it cuts through the y-axis. And what we do is we put them together. We say that y equals something x plus something. And in this case, the gradient is the amount that goes in front, so we're going to have 1x. Now in algebra you don't need to write the 1, so I will show you another way of writing this. And the intercept, which is the 2, goes at the end, plus 2. But I would have accepted the answer y equals x plus 2, because in algebra that means 1x. That there is 1x. We don't actually have to write the 1 if you're doing a 1. Okay, so that's why you're allowed to write it like that and it would still be correct. But both of those answers are correct answers. 1x plus 2. Let's do a different one. Now this works best if I have grid lines on. I need to make it so that I always create it with these pages, because I think it's much easier when we're doing these. And then we're going to start off with a shape, which was the XY graph. I've apparently put it behind myself, so let's move it over somewhere where it's useful. There we go. And then we're going to do a new line on here by going dooby dooby doo. Remember, you have to go doobie doobie do. If you don't go doobie doobie do, you actually ruin all of maths. So it's very important to go doobie doobie do. There's my line. It's apparently changing around, so I need to change it. And there is a corner, and there is a corner. So I go along 1, up 2, and my gradient, this is what we've learnt today, the gradient is the rise over the run, which is 2. But what we're finishing off the lesson with is, we can see that that's plus 1. So we can write y equals something, excuse me again, something, yes, I must be hay fever or something. Something x plus something. We then work out that this number is 1, so that's the y-intercept, so it goes on the end, plus 1. This number was 2, it's the gradient, so it goes before the x, so it's 2x. And there's more exploration you can do on that, and I've got videos which show you how you can find parallel lines. Yesterday's higher tier GCSE was all about perpendicular lines. So that today has been going through how you find the gradient of different lines. Hopefully it's made sense. There is a web link I've put in the description, which should be able to allow you to do lots of different exercises depending on what level you get up to and how you actually understand it. It's got some interactive questions. Let me know how you get on in the comments. If you've got any questions, please put them in the comments. I hope you've learnt something today. And if so, do consider putting a like on the video. I'm growing the channel to try and support as many people as possible. And what I'm going to be offering once lockdown all finishes and everyone's back to schools in September and things, I will be offering people the opportunity to do interactive tutoring with me. So I'll be able to do Skype calls and things and do tutoring for any parents who want to get tutoring. So if you've got any feedback for me, any topics you'd like me to do, let me know and I will try and do a video on it. Thank you for joining me. I've been Mr. Harris. You haven't. Look after yourselves.